Welcome to Mastering Machines, where we discover tomorrow's reality.
Hi everyone, welcome to Mastering Machines, where we discover tomorrow's reality. Did AI replace a software engineer's hand? A couple of months ago, a software engineer by the name of Erik Schluntz, who works for Anthropic, the same Anthropic that created Claude, broke his hand while biking to work in San Francisco. After that, he was only able to type with his left hand, but by using a combination of Claude, a lot of the voice-to-text features with it, he was able to write a tremendous amount of code still while having a broken hand. Through Claude and these voice-to-text features, he was even able to generate 3,000 lines of code during one particular week. I want to talk about how he was able to navigate getting his task accomplished with this kind of configuration with his hand broken, and how this will be used for software engineers in the future. Erik mentions that he had used Microsoft Copilot previously for AI code generation, but a majority of his code that was used was still handwritten by himself. He talks about his kind of love-hate relationship of voice to text, talking about how Mac really wasn't that accurate and it couldn't contextualize certain terms in reference to how he wanted it to be used. And then he started using Claude for a majority of the voice to text functions. He says this in regards to using Claude for that very feature. It wouldn't always succeed on the first try, but Claude was receptive to follow-up instructions and tweaks. I felt like I was pair programming while somebody else was driving the keyboard. He also talks about how with Claude he had to manually stitch together certain parts of the code and also kind of raise his voice and make certain that he was giving it specific examples and instructions, because just like most of these AI models, and when you're even doing prompting, you get way better results if you give them specific instructions and examples. He mentions that specifically migrations and refactors of his code base were really useful when using Claude. He would use a manual example to, let's say, refactor or manually input something in, and then he would have Claude use that as an example, and then they would transform the rest of the inputs based off of that. He was able to refactor 3,000 lines of code pretty quickly, he says. One of the cooler things of this article is that Erik used Claude on a weekend robotics project that he had with one of his friends, and they gave Claude all of the code snippets that were associated with it and to control basically a single motor in the robot. And it read their Bluetooth joystick. When they did this, Claude was able to get everything correct in the first try. So Claude was able to write all the code and able to control this robot in one shot, and able to basically get rid of a lot of tedious, kind of in and out work and data plumbing that they would have done otherwise. Also, another thing that was really useful for them, and has been also useful for me as well when using any of these AI models, is having it read a particular long document and give key takeaways or specific points. In their example, they had Claude read a 100-page document that had to do with the robotic engine, and they have them basically look at it and actually go through it and carefully read those items and tutorials so they can have some reference for it themselves and not have to worry about going page by page for this particular document and save a ton of time. One part of the article, he talks about how he's able to engage with the code base, and I'm assuming that many developers and coders use LLMs in the same way. He stated this: I started to build up a very good intuition of what kinds of things Claude could get right and what I should still do myself. Knowing this distinction saved me lots of frustration in both directions. So for things like refactoring large chunks of code, it works really well and it's able to save tons of time. But if an LLM can't fix a bug, typically within 1 or 2 tries, it's time for the coder or developer themselves to actually dive into the code and try to fix that bug themselves. Another thing that LLMs are great at doing is kind of building these throwaway tools or tools with one-time use for yourself or your use case. In Erik's example, he needed GPS coordinates that need to be sped out via a CSV file for his robot. Before, they might have had to manually inspect these coordinates or, actually analyze it by hand. But with Claude, they were able to give the first 2 rows of the CSV, and it generated a web app for them to render an uploaded CSV of GPS coordinates on top of the satellite images. So it was all of everything that they needed, and instead of taking hours of time, it only took minutes. AI in software engineering has evolved rapidly. Initially limited to IDE autocomplete, which is, GitHub, Copilot, and programming Q&A, which, typically has been ChatGPT, it now offers deeper integration into IDEs, quick prototyping tools, and end-to-end automation of engineering workflows. The future may bring convergence into an AI engineer system operating in 2 modes. The autonomous mode, handling 80% of well-defined tasks independently, and then there's going to be a second kind of system where there's going to be kind of a pair programming mode, collaborating with humans on complex tasks through multimodal interactions. The AI engineer would have access to company knowledge, proactively use contextual information, and dispatch sub-agents for simpler tasks. While potentially surpassing human engineers in specific areas, it may still require guidance on occasions similar to current management practices. He puts this great chart in his article that I really think is going to be kind of a modern day framework for a lot of software engineers and coders on how they want to interact with AI and LLMs. We'll take a look here. So a lot of the talk with a lot of tech industry people is the fact that will we need humans in software engineering in the future? And the short answer is yes. AI in software engineering is comparable to calculators in accounting. It elevates a human work to a higher level of abstraction without replacing the need for human expertise. AI will democratize software creation, enabling more people to build apps and tailored tools. But human engineers will remain essential for high-level prioritization, understanding the overall architecture and scope of a web app or a particular program, reviewing AI's work, especially in the large systems. He goes on to talk about how engineers will focus more on what to build rather than how to build it, addressing the inherent complexity of problems instead of incidental complexity of implementation. Also, Erik has now recovered from his injury and continues to use Claude for coding and is optimistic about the industry's future with these new tools. This has been Mastering Machines. Remember, discover tomorrow's reality.